2.3, apply deductive reasoning. So we started out in chapter 2 with 2.1, which was inductive reasoning. And you'll see right here, I did a quick reminder for you that inductive reasoning uses examples, patterns to form a conjecture, which may or may not be true. So inductive reasoning is often based on just observation. Now we're going to start deductive reasoning, which by definition up here uses facts, definitions, accepted properties, and laws of logic to form a logical argument. Okay, so we're switching from inductive to deductive, but through this lesson, we will compare them quite a bit so you can see the difference between them as well. All right, we start off with two laws of logic. The first one is the law of detachment. If the hypothesis of a true conditional statement is true, then the conclusion is also true, okay? You'll notice over here, this is called a direct argument, okay? So when you're given if this happens, then this happens. So if the if comes true, the then comes true. It's just a two-part rule, basically. Law of syllogisms says if hypothesis P, then conclusion Q. If hypothesis Q, then conclusion R. And because we see a match with then conclusion Q, if hypothesis Q, we get rid of that connecting link and we go to if hypothesis P, then conclusion R. This is the law of syllogism, and this one is sometimes called the chain rule because of being able to shorten the chains between those links, okay? All right, so let's start off with just the law of detachment, okay? You'll notice in the margin, I gave you a quick rule here, and if you do want to probably write this down because this is probably the easiest way to remember law of detachment. It's a rule with two parts. If one part of the rule is true, the next part also comes true, okay? I can't stress enough for this law of detachment. Don't think you have to come up with some grand new idea or anything. Everything is given to you. You have a two-part rule. If one part's true, the other part's true. You don't have to think of anything new here, okay? So let's do our first example. If two angles have the same measure, then they are congruent. So here's my two-part rule. If two angles have the same measure, so same measure is one of my parts. Then they are congruent. Congruent is the second part. So there's my two-part rule. Okay, they tell me you know the measure of A equals the measure of B. So which part came true? The same measure. So what's my answer? Angle A is congruent to angle B. So they told me same measure, I tell them congruent. I don't think of anything new, I just say that's the answer, okay? All right, next one. Jesse goes to the gym every weekday. Today is Monday. Okay, this one's not written in if-then form. We can do that, right? We could write it if it is a weekday. Oops. Then Jesse goes to the gym. Okay, you can do that, or I'm going to be honest, if you can look up there and see the two parts, Jesse goes to the gym, that's one part, when on a weekday, you just need to see the two parts. So whether it's an if-then form or not, it still works that way. They tell us today is Monday, that covers the weekday part, which means what's my conclusion? Jesse goes to the gym. Okay, so you are just looking for a two-part rule. When one part of the rule comes true, the second part is the answer, okay? All right, second page. We're going to start second page with law of syllogisms, okay? I know it's a big word, but once you know kind of what it's going on here, it's not too hard. So in the margin, again, I gave you a note so you know what law of syllogisms is. It says look for a connecting link, one if, one then. You take out the link, and you rewrite what is left. Okay, so we're looking for connecting links. And this is also called the chain rule because if you think of a long chain, you have all these links connecting it. Well, if you want to shorten the chain, you can get rid of some of the links in the middle and reconnect the links on the end. So you shorten things up. And that's what we're going to do here. We're looking for things that connect in the middle. We're going to take them away and shorten what's left. Okay? So our first one here. If Ron eats lunch today, then he will eat a sandwich. If Ron eats a sandwich, then he will drink a glass of milk. Well, I see eat a sandwich twice, right? And I look and I have then he will eat a sandwich if Ron eats a sandwich. So there's my connecting link. I have one if, I have one then. So I'm going to take out those links. I'm going to just cross those off, and I'm going to write what's left. If Ron eats lunch today, then he will drink a glass of milk. Okay. All right, so second example here. If x squared is greater than 36, then x squared is greater than 30. If x is greater than 6, then x squared is greater than 36. I see an x squared greater than 36 twice. I check. I have one with a then, I have one with an if, which means I have connecting links and I can get rid of them. And I have to rewrite what's left. Always remember, our sentences start with if, so I need to start with if x is greater than 6, then x squared is greater than 30. So just make sure you put the if first and the then second, so it stays that hypothesis and conclusion. All right, third example here. If a triangle is equilateral, then all of its sides are congruent. If a triangle is equilateral, then all angles in the interior of the triangle are congruent. I see triangle equilateral. So I see something matching. This one has an if. This one has an if. That's not good for us. We need one if and one then. Since I have two ifs, I cannot cross off a connecting link. They don't link correctly. So neither statement's conclusion is the same as the other statement's hypothesis. So you cannot use the law of syllogisms to rewrite this one. So that one we're just done. There's no law of logic being used there, okay? All right, 2 at the bottom here. The first one says, if 0 degrees is less than the measure of angle A, which is less than 90, so here, then angle A is acute. The measure of angle A is 38 degrees. Use the law of detachment. What statement can you make? Well, law of detachment is our two-part rule, okay? So my first part here is if my angle is between 0 and 90 degrees. My second part, the angle is acute, okay? So there's my two parts. They tell me the angle's 38. That falls under the first part. My job is to find the second part, and I just say angle A is acute. Okay, don't think of it, just write the second part of the rule. All right, second one here, it says state the law of logic that is illustrated below. If you do your homework, then you can watch TV. If you watch TV, then you can watch your favorite show. If you do your homework, then you can watch your favorite show. So we started with these top two sentences. It looked like I had, you can watch TV if you watch TV. So connecting, one had a then, one had an if. They got rid of them, and they just shortened, if you do your homework, then you can watch your favorite show. So that looks like we shortened up the chain. That's our law of syllogism. All right, page 3. Okay, page 3, we're going to do the same example once with inductive reasoning and once with deductive reasoning, okay? So a reminder in the margins here, inductive reasoning says we're going to guess what's true by seeing examples, okay? So we're going to look up here first and we're going to do some examples to try to figure out what's going on. They said, what conclusion can you make about the sum, that's when I add, of an odd integer and an odd integer, okay? When we do inductive reasoning, we're just looking for some patterns. So you can choose some odd integers to add together. They chose -3 plus 5. A negative and a positive, I get a positive 2. They went with -1 plus 5. I get positive 4. They went with 3 plus 5, so 2 positive numbers. I get 8, I'm sorry. -3 plus -5, so 2 negatives. I get -8. 1 plus -5, so my bigger number is negative. I get -4. 3 plus -5, I get -2. So they gave me quite a few examples. I got some answers. The conjecture, remember, just a logical guess based on what we see, says odd integer plus odd integer equals, looks like an even integer, okay? Based on just looking and observing, that's what we get, okay? So this was inductive reasoning. We made some patterns, we figured it out, we came up with that, okay? Now, We're going to switch it over this time on the bottom, and we're going to do deductive reasoning, which is proving it's true by using facts and accepted properties. Okay, so as we go through this one, we're still going to be checking those odd integers and odd integers added together. But we don't want to just choose a random odd number. We want to choose something algebraically that represents an odd number and all odd numbers, because there's infinite number of odd numbers. Okay, so this one, and don't get overwhelmed with this example, okay, because I'm not going to ask you to do this all on your own, okay? I just want you to see this example and walk through it, okay? So we have integers, okay, and integers are positive or negative numbers, whole numbers basically, okay, is what we think of them as, okay? But if I just tell you I have an integer n, I don't know if that's even or odd. It has to be one of them unless it's 0, but I'm not sure which. Well, if I multiply it by 2, that has to now be even, because anything multiplied by 2 is even. Same thing with m, right? If I have m and I multiply by 2, those have to be even. So how can I represent an odd number? Well, how far away from an even number is an odd number? It's just 1 away, right? So I could take and I could subtract 1, or I could take and I could add 1, and now I have odd numbers, okay? Because if 2n and 2m were even, then 1 away from them would be the odds, okay? So this is kind of what they're walking through here. 2n and 2m are even integers, because anything multiplied by 2 is even. That's what this is saying, and that matches what we just drew over here. 2n minus 1 and 2m plus 1 are odd integers, since 2n and 2m were even integers. Okay, so that's what these two lines are saying, what we just kind of wrote on the side here. Okay, now it says, let's go ahead and add those two together, okay? I'm going to be honest, what they start writing here kind of looks messy. So let's just add 2n minus 1 plus 2m plus 1, okay? Well, my 1's cancel, and I get 2n plus 2m. That's what I'm left with. I really can't join them. They're not like terms. Okay, this is looking a little bit funny here, but if you remember from algebra, I can't join those, but because they both share a 2, that's called the greatest common factor, I can factor out a 2 and be left with n plus m, okay? And that's what I'm going to kind of cross off this because it's confusing, and this is what this line right here says, okay? All right, so this is what I get when I add 2 together. Well, if I have this 2 out front, that means my answer has to be even, because anything times 2 is even, okay? So what this is proving is that when I added 2 odd integers, I had to get an even integer, okay? Is that what we set up here? Definitely. But down here, I did it with deductive reasoning. I used facts to show the same thing, okay? I didn't use just random numbers. I used algebra, which can show that it'll be true every time I choose an integer there, okay? Okay, are you going to have to do that on your own? No, okay? But I do want you to see it. So let's try this one down here. And again, I'm going through it with you. I want you to see it, but you're not going to have a lot of these that you have to do on your own, okay? So we're going to do one inductive, and that's finding patterns, okay? And we're going to do one deductive for the exact same type of problem, okay? It says use inductive reasoning to make a conjecture about the sum of a negative integer and itself. Then use deductive reasoning to show that your conjecture is true. Okay, so inductive means I need to find a pattern. I need to see something. So you're going to choose any number you want, a negative integer, and we're going to add it to itself. All right, you want to try -5? We can do -5. -5 plus -5. We add it to itself, we get -10. All right, that makes sense. Let's choose another one so we can see a couple patterns. You want to choose a bigger number? Okay, how about, let's go with an even one, right? Like -100. It's bigger, it's even, plus -100. And I get -200. Okay. We could keep going, right? But let's go ahead and write our conjecture, okay? What do you notice when you add a negative integer plus itself, right? So a negative integer and plus itself is what? A negative, okay, is a negative And what else do you notice? Oh, they're even, right? Even integer. Okay. I would say both of our examples are there. I think if we came up with another example, we're still going to get a negative, and we're still going to get an even. Okay. So that's what it looks like with an inductive. We find a pattern and we make a conjecture. We make a guess based on our observation. For deductive, okay, I'm not going to choose one number. I'm going to go ahead and say like negative x, right? That's a number. I add it to itself. What's negative x plus negative x? Negative 2x, okay? What does this tell us every answer is going to be? Negative. What does this 2 tell us every answer is going to be? Even. Does that match the negative and even that we came up with in our conjecture? Yes, okay? So this is the deductive that I used some facts that will be true for everything. And then this one over here was the pattern that I noticed for the ones I did, okay? That's the difference between inductive and deductive. They sometimes can get the same result, but the path we use to get there is slightly different, okay? All right, back page. And this is just going to walk us through some inductives and deductives to know the difference. Okay. So we have a chart here on the back, and it talks about the average running speed of a runner, okay? So this is the speed here, and you'll notice my speed goes up as I go up the graph, and this is how long I've been running, the time, as the time increases. And it looks like it's going from 0 to 60 minutes, so about an hour of running. What happens to our speed? So in A, it says the runner's average speed decreases as time spent running increases. And the question is, are they basing this on inductive reasoning, they looked and they saw a pattern, or are they basing it on deductive reasoning where they have some facts that go with it? And anytime you look at a graph and you're looking at just kind of like the trend, right, what's kind of happening, that's a general observation. That's just based on, what you notice as a pattern. So I'm going to call that one inductive reasoning because it's based on that pattern. Okay? Now, for the second one here, it says the runner's average speed is slower when running for 40 minutes, so I can go to 40 minutes and get like this number right there, than when running for 10 minutes, so I could use this number right here. Okay, if I have some numbers that go with their statement, and I could run, my calculator, and I could run to find average speeds in something, is this inductive or deductive? And we're going to call that deductive because we're basing it on actual values, okay? So the actual values will make it deductive. All right, I've got a few more down here. 4, 5, 6, and 7 down here. We're going to just, the same thing. Are they inductive or deductive? So I'm hoping after going through a few of these, it'll be easier for you on your homework to know the difference. So number 4 says, for the past 3 Wednesdays, the cafeteria has served macaroni and cheese for lunch. Dana concludes that the cafeteria will serve macaroni and cheese for lunch this Wednesday. Is this based on facts, or is this based on patterns? Well, I think this is just a pattern from the last 3 Wednesdays, so we're going to call this inductive, okay? And that's based on a pattern. All right, number 5, a lawyer defended a murder suspect in court, and the lawyer proved that the suspect had an alibi during the time of the murder. So the lawyer won the case, and the suspect was set free. Is that based on facts or based on patterns? Well, I would say an alibi creates a fact there, so that's going to be deductive, okay? So they use some facts on that one. For number 6, you use the rise of 8.1 and the run of 2.7 between 2 points on a line in the coordinate plane to conclude that the slope of the line is 3. Do we use a pattern, or do we use facts or numbers to support those facts to find a slope? I would say we definitely use some numbers or facts, so that one's also going to be deductive. All right, and our last example here, Josh knows brand X computers cost less than brand Y computers. All other brands that Josh knows of cost less than brand X. Josh reasons that brand Y costs more than all other brands. Is it based on patterns or based on facts? He's definitely observed different prices over the time, but it doesn't look like he has any prices. It doesn't look like he has any data. It looks like it's just an observation. So I'm going to call that one inductive as well. Okay? So deductive reasoning, facts, things you can prove, and inductive is based on patterns. okay? Try your worksheet. If you have questions, let me know.